So in this coprime function output, we first enter a number 14, the second number 15. The numbers 14 and 15 are coprime. Do you want to continue? Yes. Enter a number 14, 16. They are not a coprime. No, it exits. I have used two functions. The first function, coprime test loop, where we get the two inputs, first number and second number, as integers, and then we pass those two numbers to the different function coprime, where we use the GCD algorithm of replacing the biggest number with the remainder. This loop continues until the remainder becomes 0. We use while loop to satisfy it, and also we check whether it is equal to 1. If it is equal to 1 and returns true, which means the numbers are coprime. If it is not equal to 1, it returns false, which the numbers are not a coprime. So we again ask a question, uh, does the user want to continue? And we have an if statement, and suppose if the user wants to continue, we again call the coprime test loop function. So we continue the same function. It loops on until the user does not want to. So if the user enters no or anything else, the function exits out of the loop. The efficiency of the function is based on the Equilion algorithm to find the GCD. In the while loop, we replace the biggest number with the remainder. This loop continues on and on until the remainder becomes 0. After that, we check if it is equal to 1. If it is equal to 1, the numbers are coprime. If it is not equal to 1, they are not a coprime. The code assumes that the user enters a valid integers for the two numbers you get as an input. And also it assumes that if the user wants to continue the loop, he enters the valid response yes. Also, continue test loop is a recursive function. If the user wants to continue for large number of times, it may lead to stack overflow, and only then the code will crash.